Good afternoon, ladies and gentlemen. Today we will be recording a video on metallic micro-lattices. This is done through the Department of Chemical Material Engineering, Chme 361. This project was done by Andres Caballero, Ethan Amaya, and Julian Heckman.
This is the introduction to metallic micro-lattices. A metallic micro-lattice structure is made through the use of bioplastics and metal templating. It's possible through the manipulation of physical and chemical properties of the material because of the advancements in metal processing. It's leading in material engineering advancements that can be used in commercial infrastructures. The two infrastructures that it could be used for are in the automotive industry and the aeronautic engineering field. What makes metallic micro-lattices so important is their structural properties relating to the material's weight.
Next, I will be talking about the metallic micro-lattice structures. Micro-lattice structures consist of microstruts stacked in different arrangements. Most of the volume is occupied by air voids. Micro-lattice structures are affected by various factors including where the parent material is manufactured and what manufacturing technique is used. Micro-lattice structures predominantly demonstrate a bending dominant stress-strain behavior, giving it a favorable advantage as a shock-absorbing material. This material also has a blast-absorbing property, which allows it to be used both in the aerospace and automotive industry. Having the blast property lowers the kinetic energy, allowing for the material to absorb a lot of the stress that the material would occur during testing. Next, we will be talking about the process.
I will be talking about the process of metallic micro-lattices. There are two processes that can be used, one which is colloidal crystal lithography and the other which is 3D laser lithography, each which defines the lattice structure. Through electrodisposition, the nickel gets templated onto the bioplastic lattice structure. If it is electroless disposition, it will create a hollow shell opal instead of a metal inverse opal, which is gained through electrodisposition. On the top part of the diagram, it shows how the bioplastic is made to the structure and how electroless plating is put onto the bioplastic. The bottom half of the structure diagram shows how the structure looks under a microscope.
On this slide, I will be presenting the applications of metallic micro-lattices. Many renowned universities are studying possible applications for a metallic micro-lattice structure such as impact protection, aerospace engineering, acoustic damping, and automotive engineering. One way it could help in the aerospace engineering is by lowering the weight of airplanes, which could result in less fuel consumption. Then for the automotive industry, it could make a substantial impact because Glenn Dainth, a researcher at Ohio State University, reports for every 10% in weight reduction, a 7% improvement to fuel economy could be created. Another application for a metallic micro-lattice can be incorporated into the body of a car because the high resilience of the micro-lattice it could make the cars resistant to accidents. Next, we will be introducing global environmental impacts of metallic micro-lattices. These pictures on this slide represent the structures and applications of metallic micro-lattices.
Next, I will be describing the global and environmental impact of micro-lattice structures. Micro-lattice structures have little to no environmental impact. A micro-lattice structure can be manufactured in 30 seconds or less. The main component of a micro-lattice structure is formed with environmentally sound bioplastics that only require UV curing for their process. Bioplastics are a degradable material that come from renewable resources and can be used to help minimize the contamination levels in the environment. The use of this technology makes up a small portion of the plastic industry. In the manufacturing processes, the steps used to create micro-lattice structures have little to no effect on the environment. The impact that it has globally is that it could revolutionize material manufacturing, being 99.99% of air allows the material to be used in multiple industries. The production of the micro-lattice is cost-effective, which in turn gives more efficiency to the customer while minimizing a negative effect on the environment.
This slide will conclude metallic microlattices. It's a new revolutionary idea which has led us to advancements in chemical and material engineering. As technology increases, it will become more widely available to being cheaper to use commercially. With more research, more improvements can be made to existing problems. With this, I would like to thank Professor and TAs for providing us with a great engineering topic. Thank you.